Oversuppression of wildfires in the 1900s and anthropogenic climate change has caused an increase in the occurrence and severity of wildfires in North America. Silv-Ex Plus Class A fire control concentrate is marketed as a biodegradable fire suppressant commonly used in the Upper Peninsula of Michigan for wildland firefighting. It is commonly used to control fires within jack pine stands, which often have streams containing brook trout within them. Our goal was to determine the LC50s in age 0 and age 1 brook trout in temperatures of 12°C and 15°C. These temperatures are typical of what you would expect to see in spring and summer, respectively. After determining the LC50s, we then tested for behavioral avoidance and exposure of 25% LC10 and 75% LC10, respectively. Our goal was to determine if age 1 brook trout were able to detect Silv-Ex Plus Class A fire control concentrate, and if they could, would they be actively avoiding it or be attracted to it?
Our initial goal was to determine the lethality of this chemical to brook trout. In order to test this, fish were divided equally into 4-foot diameter round tanks held at one of two temperature groups, 12 degrees Celsius or 15 degrees Celsius, for at least 14 days prior to any trials. A diagram of the experimental system is provided in Figure 1. During the acclimation period in experimental trials, fish were housed in static 5-gallon containers filled with 12 liters of water and covered with a mesh cloth. After the acclimation period, chemical is introduced into the system at the appropriate concentration. Following the testing guidelines set forth by the OECD, a control with no chemical and 4 treatment concentrations were used for each temperature group, with treatment concentrations varying by 10 milligrams per liter. 5 trials were conducted for each temperature group, with each concentration being tested each of the 5 locations to account for any of the possible location bias. Lethality trials lasted 96 hours, with fish being checked at the specific increments noted, and any dead fish were removed. Behavioral trials used age 1 Acinica strain brook trout. Avoidance behavior was measured by adding individuals into a trial chamber consisting of an open field and 2 cover zones on opposite ends of the chamber. A detailed diagram depicting the trial chamber setup is included in Figure 2. Water and diluted chemical were added at a rate of 0.36 liters per minute over a 10-minute period through airline tubing located at opposite ends of the chambers. In order to achieve uniform distribution of water or diluted chemical, 4 tubes of equal spacing were used. Fish were acclimated 1 hour before trials began. Treatments were 25% LC10, 75% LC10, and control. Treatment zones were randomly assigned based on the location of the fish at the end of the acclimation period. Time spent per zone was recorded and analyzed using Noldus ethovision.
The lethality results, the extrapolated LC50s were higher in age 1 fish than young of the year fish for both temperature groups. Temperature did not appear to influence lethality in young of the year fish. The extrapolated LC50 was higher in age 1 fish at the 15°C water temperature than in the 12°C water temperature. For the behavioral results, a Kruskel Wallace test by ranks produced non-significant results when the differences between time spent in the 25% LC10, 75% LC10, and the control zones were examined. This non-significant result may be attributed to our low sample size. In order to account for our low sample size, we combined the 25% LC10 and 75% LC10 data and analyzed it as a chemical versus control treatment using a Mann-Whitney U-test. The Mann-Whitney U-test showed that there was a significant difference between the time spent in the chemical zone versus the control zone.
Taking our results into account, we were able to determine that water temperature may be an important factor when it comes to the lethality of Silv-Ex fire foam to fishes. It is also worth noting that young of the year brook trout were more sensitive to this chemical than age 1 fish were. When it comes to avoidance behavior, our initial analysis using a Kruskel Wallace test by ranks indicated that there is no statistical difference between the median time spent in the control zone compared to the 2 chemical zones. However, we did notice that there is an observable trend that led us to combining the chemical zone data in order to do a simple comparison of chemical versus no chemical. This test showed that fish avoided any of our chemical treatments. Overall, our results suggest that the introduction of Silv-Ex induces avoidance responses in brook trout. It is important to note that our insignificant Kruskel Wallace values could possibly be attributed to small sample sizes due to COVID-19 restraints. This could also account for our lack of a 12 degrees Celsius temperature group in our avoidance trials. The active avoidance of Silv-Ex demonstrated by brook trout in our tests suggests that they are capable of limiting hazardous exposure to this chemical. Although some may see this as advantageous for the fish's survival, it is important to note that long-term avoidance in natural settings could result in displacement from preferred habitats and the loss of viable populations, according to a study done by Wells et al. In 2004. Increased awareness for fire management applicators is necessary in order to facilitate safe application and promote the health of aquatic ecosystems and species that rely on them. More research should be conducted on the current state of the rate of application that these brook trout may be exposed to in the wild, as well as riparian vegetation density in these habitats, as past studies have shown that intact riparian vegetation may be sufficient to largely eliminate the movement of this chemical from land to stream.